Hi, I'm Dr. Tim Floyd, and today we're going to talk about solving quadratic equations. Now, this is a very important skill because it's used in several areas in algebra where you don't just solve quadratic equations. Later on, when you work on parabolas, you'll be finding zeros and x-intercepts. This is the skill you need in order to be able to do that. First of all, let me talk a little bit about what is a quadratic equation. First of all, a quadratic equation has only one variable. That is, if it has an x in it, it doesn't have any other letter in it. It has only positive integer exponents. 0, 1, 2, 3, and so on. You do not have any variables in the denominator. Okay, let me get my little marker here. We have one variable, only positive exponents. We have no variables in the denominator. Now, that can happen for other types of functions, but for quadratic that we're going to be working on, we do not need any variables in the denominator. Now, what makes it quadratic is that the highest exponent is 2. Now, what I have at the bottom of this slide is two examples of quadratic equations. First of all, notice that you only have x and that the highest exponent is 2 and that there are no variables in the denominator. Okay? Now, the numbers in front, which if you remember they're called coefficients, the numbers in front can be any type of number. They can be integers, they can be fractions, it could be decimals. But the important thing is that the variables have positive exponents and you have no variables in the denominator. So if you look under the non-quadratic side, you will notice that we have an x in the denominator. And that makes it non-quadratic. It means we cannot solve it with the methods that we're about to use. Now, in the second one, my slide I messed up a little bit. I meant for this to have a -3 on it to show you that negative exponents aren't allowed in quadratic equations. Now, it doesn't mean we can't solve these. It just means that the techniques I'm about to show you don't work with other kinds of equations that are not quadratic. Now, in order to solve a quadratic equation, there are several ways this can be done, but there are two primary methods that we use, and I'm going to demonstrate them both. First of all, we can factor. Now, the key is with factoring is you have to remember there's all types of factoring. You have trinomials, you have the sum difference of two squares, you have greatest common factor. So in order to do this section well, and I really don't have time today to go over everything, but you need to review all of your types of factoring. The other method that can be used is a good old tried and true friend, the quadratic formula. And maybe some of you know the little song that goes with the quadratic formula. Now, in either case, whether you're factoring or using the quadratic formula, it's very important that before you start to solve, the equation has to be set equal to 0. If it's not equal to 0, then you need to manipulate the pieces of the equation so that using solving techniques so that it is equal to 0. And I will demonstrate that in some of the problems that we're about to do. So now let's get into some examples. Okay? First of all, you will notice that the equation is set equal to 0 and that we have one variable and the highest exponent is 2, so that this is set up now. This is a quadratic equation. Once you have determined that it is quadratic, then you can look and try factoring. Now, factoring may not work. Some equations don't factor. Some quadratic equations will not factor. So you have to be very confident in your factoring because you have to know when you have to stop, and if you can't factor it, then what you do is switch to the quadratic formula. Quadratic formula will always get you solutions or tell you that there aren't any. Whereas factoring, the equation may or may not factor. So now if we go back to the problem, we have it equal to 0. So if we look at this trinomial, now there are various methods of factoring trinomials. The most common method that you probably were taught was trial and error. If you remember, we need two numbers that multiply to give us the 10, and it's negative, but we have to be able to add them to get negative 9. Now there's only one way to get x squared, and that's have an x at the beginning of each binomial. Now there are two ways to get 10, 2 times 5 and 1 times 10. And I want it negative, so if you think about 2 times 5 and 1 times 10, and you want to be able to add these to get negative 9, the only way for that to happen is if the 10 is negative and 1 is positive. Now this one's kind of friendly for us because we don't have a number in front of the x squared, but as I said, you need to practice your factoring. So, and it doesn't matter what order we write these in, we're going to factor. Now the last thing you always want to make sure before you move on in the solving is make sure this is correct. So I want to take this and I want to use FOIL to check. And when we check this, we get x squared, we get minus 10x plus 1x minus 10. Oops, I'm going to reach the edge of my board. And if you add these two, we do get negative 9x, which matches our original problem. So we have factored this correctly. Now, in times past in basic algebra, factoring was its own answer. This would have been the answer, but now we're taking it a step further. We're now going to use these factors, since it's equal to 0, to solve for the values of x that would make the original equation equal to 0. And the way we do that is we use the property that says that if we multiply two numbers and we get 0, then one of the two numbers has to be 0. So in this case, if we look back at the problem then, we have x plus 1. We want to set it equal to 0, because if that one's equal to 0, then we get a solution of 0. Or x minus 10 could equal 0, and that gives us two possible answers. So now we solve these. So we subtract 1 from both sides, and we get x equals negative 1. If these steps of solving these equations are difficult, you may need to go back and review solving basic equations. Now in this case then, we want to add 10 to both sides, and we get x equals positive 10. So we get two values that will make this equation equal to 0. Now, I won't take time to check both of these, but let me just show you what you would do if you really wanted to make sure you had the correct answer. We would do a check, and what we would do then is substitute one of these answers in, or both of them, at different times of course, to see if we have a correct answer. So if we plug in negative 1, please keep in mind one of the most common mistakes is that when you're squaring a negative number that's been put in for a variable, the negative gets squared also. So this becomes positive 1. Negative 9 times negative 1 makes it plus 9 minus 10, which then does give us 0 equals 0. Now, if we checked positive 10, we would also see that this equation comes out to equal 0. Now, depending on your instructor, they will ask you to write answers a variety of ways. The simplest way is to simply write as the answer x equals 10 or negative 1. Now, some teachers may ask you to write it in a more formal method using set builder notation. So the solution is the set, remember those weird braces, the set of all numbers x such that x equals 10 or negative 1. and then we put our braces at the end of the answer. I guess I could write that just a little neater there. Okay. But the key is that the solution is one of these two numbers. Now, let me write it down here just a little bit. Okay. Okay. Doesn't like writing near the edge, so let me do this. I'll be honest. We got plenty of time here. Let me write this a little more neatly, okay? The set of all x such that x equals 10 or negative 1. And then we close. Ta-da! Got it. Okay. So it's up to, you need to find out from your instructor as to which way the final answer would be written. Now, later on, you'll be doing graphing of parabolas, which are quadratic equations. These solutions, if you have solutions, will be the places where the graph connects with the x-axis. So that's one place that this skill is used. Finding solutions to equations in higher level algebra, this skill pops up quite often. Now keep in mind, we can't always do it by factoring. Okay? All right, so let's move then to the next problem. And here again, we have a quadratic equation, single variable, highest power is positive 2. And by the way, for those of you, remember that the exponent, when it's not there, is 1. Now, one of the things that might help later on is to keep in mind that there is a variable on the 3. But what happens is it's a variable that has a 0 power, x to the 0. Now, we don't normally write x to the 0 because if you remember, x, anything raised to the 0 power becomes 1. So 1 times 3, oops, let me write my 1 neater, gives us 3. So that's why we don't normally see the x written when it's x to the 0. But for some things that you'll do later on, you'll need to remember that a constant number does have a variable with it. It's just raised to the 0 power. Now, in this case, we have a trinomial that needs factoring where we have a coefficient in front of the x squared that's different from 1. Now, trial and error involves making sure that wherever we put the numbers that we end up with a positive 8 in the middle. Now I'm going to cheat just a little bit because I know what the answer is. I'm the teacher. I know what the answer is. So we know that we need to get 5x squared, and since 5 is a prime number, there's only one way to make 5. That would be 1 times 5. So I know I need an x and a 5x. Now the key is, where do I put the 3 so that when I do the FOIL, I'll get an 8 in the middle? Well, if I put it here, and if I put a 1 here, and these are both positive, what happens, and that's why you have to be careful and make sure you check. If I do 8 times 1, that gives me 1x. 3 times 5 is 15x. That adds up to 16x, and we want 8x. So what that means then is that I need to put the numbers in a slightly different place. So now I will start over, and by the way, you need to get used to in algebra using a lot of paper because trial and error does give us a lot of work to do, and sometimes it's not right, so you need to be prepared to take up some more space on your paper. So what we need is, I don't need to 5 times the 3. I need the 3 in the term with the 5. And now if we check this with FOIL, let me draw a little line here. So 5x times x is 5x squared. 5x times 1 is plus 5x. 3 times x is 3x. And 3 times 1 is 3. And when we add 5x and 3x, we do get 8x. So I have factored this correctly. And it's absolutely essential that you check make sure if you're going to use factoring that you factored it correctly. This is another reason why you can, if you learn how to use the quadratic formula correctly, you don't have to worry about this, because the quadratic formula, you simply plug in coefficients and doing the formula takes care of all of the confusion. Whereas if you factor, you've got to make sure you've factored correctly, check your factors before you move on and solve. Okay? So now if we come back to the equation then, we have it's equal to 0, and using the property that says if two numbers multiplied equals 0, one of them has to equal 0, I take 5x plus 3 and set it equal to 0. I take x plus 1 and set it equal to 0. So I have, when I solve this, we get 5x equals negative 3. Divide both sides by 5, and we get x can equal negative 3/5. On the other side, I subtract 1, equals 0, excuse me. I know one of you were screaming into the screen, that needs to be 0. Never be afraid. Hopefully you have teachers that will always let you tell them that they've written something wrong. So I heard somebody saying that. So now I want to subtract 1 from both sides, and we get x equals negative 1 as our other solution. Now, here again, you've all got calculators you can use, so there's no reason for you not to check these answers and make sure that they're correct. Since I'm perfect, I know they're correct. So, but never be afraid to put stuff in your calculator, because you can double check it very quickly. Most tests you take are not timed, so you'd be better off knowing that you got the right answers than simply putting answers and finding out later you should have checked. So now, again, depending on how a teacher wants you to write the solution, some teachers would just have you simply write negative 3/5 with a comma, negative 1. Or we can write it in formal set notation, the set of all numbers x such that x equals negative 3/5 or negative 1. And I find in the years I've been teaching that the hardest thing people have to do is to write these little curly Q braces. I've had a lot of people just cheat and do a parenthesis and put a little mark in the middle of it. So yeah, just a little practice will get that out of the way. Now, if we move on to our next problem then, in this case what we have is an equation that's not equal to 0 already. Now, we have a hint that this is quadratic because we do have a power of 2, but we have x plus 3. Well, anytime you have an equation that has some simplifying to do, either by combining like terms or by, in this case, using FOIL to multiply this out, if it's not already equal to 0, then what we need to do is multiply this out. Now, the number one error I find students make, and when they do this, is that they forget the middle term. They'll write x squared and they'll write 9, but they forget that there's something in the middle because they didn't FOIL it. So if we do x times x, we get x squared. X times 3 will be 3x. X times 3 will be 3x. 3 times 3 would be 9. And then if we combine the middle two terms, we get x squared plus 6x plus 9. And let's remember that this was equal to 4. Now, make sure that you FOIL that correctly, because if we didn't have the 6x in this problem, if we don't have the 6x, you will not get near the right answer. So make sure that you've got the FOILing done correctly. Now, this is not equal to 0 yet, but now we can subtract 4 from both sides. And I know this is unusual because normally when you solve equations, you want to get variables on one side and numbers on the other, but in this case, we need it equal to 0. So we subtract 4 from both sides, and what we get then is x squared plus 6x plus 5 equals 0. And that is the form that we need so that now we can solve this using factoring or quadratic formula, but this will happen to factor. Now, x squared plus 6x plus 5. It's nice that we don't have a coefficient on the x squared. We need to multiply to get 5 and add to get 6. Well, as it turns out, the only way to multiply to get 5 is 1 times 5. The only way to get x squared is x times x. And these are both positive. Now, if we check this, x times 5 would be 5x. 1 times x would be 1x. 1x plus 5x does add up to 6x, which is what we need in the middle. Now, if you try factoring, and if you cannot figure out how this factors, then you would go and do quadratic formula. Now, as we've done in the other two examples then, we take each and set it equal to 0. And we get x equals -1 and x equals -5 are the two solutions. And so now we write x equals -1 or -5, or you put it in the formal set of all x such that x equals -1 or -5. And now you have your solution. Now, I would say that the only ones you should try to factor are problems that have coefficients that are integers. When you have fractions or decimals as the numbers, then you certainly want to go ahead and use the quadratic formula. So let's get into the quadratic formula. Some mathematician many years ago, I'm not sure if it was a man or a woman, probably could have been a woman, who knows, played with equations, and quadratic equations in particular, and discovered, and by the way, if those of you who learned how to do complete the square to solve quadratic equations, which is another method, you know how to take this and change it into this grand thing that we call the quadratic formula. Now let's note some things about this first of all. This is actually two formulas, because in the middle we have this symbol plus minus. Well, that means that one of the answers is -b plus the square root. The other answer is -b minus the square root. So this is actually two formulas for the price of one. Now, it is very important, as I do these, I'll remind you that this fraction bar here in the middle, which I'm overcoloring with the red, goes completely under the -b plus or minus the square root of b squared minus 4ac. A lot of students will only put the fraction bar under the square root and end up getting wrong answers. So be very careful as you do your quadratic formula. Most of your instructors will have you memorize this, so make sure, might as well take the time and memorize it. All right, so let's look at our first problem where we're going to take advantage of this. Now, this is one that would factor, but I'm going to show you how it would work using the quadratic formula. First thing, we need it equal to 0, which it is. It's set, oops, I need a marker. It's already equal to 0, so we are ready to solve. We have one variable, x, and the highest power is squared. That's the 3 Q's that you need to be able to know that you're going to use the quadratic formula. Now, what we need then is and I'm going to write this big word, the C-I-E-N-T-S, the coefficients of each term. Well, please remember that there's an understood 1 in front of the x squared. We have -5 and +6. Now, traditionally, we use the quadratic formula uses the letter A and B and C. A goes with the x squared, B goes with the x, and C is the constant. So A is +1, B is -5, and we bring the negative with it, and C is +6. So we need those values. Now, I don't know how different teachers talk to you about the quadratic formula, but what I do is I write the structure of the formula, and wherever there's a variable in the formula, I put a set of parentheses. So we have opposite b, or negative b, plus or minus the square root of b squared minus 4ac over 2a. Now notice I said the letters, but I didn't actually write the letters. Now I'm going to say what goes in this is the b, which is -5. In this case, b, again, -5. A is 1, C is 6, and A is 1. Now, the reason I do that is the biggest mistake people make in doing quadratic formula is that they forget that in this term you are putting in b and squaring it. So if b is negative, the negative does get squared. If you put this in your calculator and you just write -5 squared without parentheses, the only thing you'll get is a wrong number. You'll get -25 instead of +25. So the only way to ensure that we do get the correct answer is to remember that the -5 is going inside parentheses where the variable was, and that the whole thing is getting squared. Now, we proceed then with simplifying the quadratic formula. The opposite of -5 is 5, plus or minus. Now, keep in mind the fraction bar goes underneath everything there. -5 squared would be +25. Now we've got -4 times 1 times +6. So this comes out to be -24 over 2. So what we have then, and I'm going to shift over just a slight bit. You do need a lot of paper when you do these, okay? So we get x equals 5 plus or minus the square root of 1 over 2. Now never be scared to remember that the square root of 1 is 1. So we have 5 plus or minus 1 over 2. Now not all of these will work out this neatly, but you need to carry it on down if it does come out this neatly. So in this case now, we have two answers. Okay, let me separate this a little bit so that I want to fit this all on the same slide, so hopefully it will be visible. So we have 5 plus 1 over 2, which would be 6 over 2, which would be 3. And then we have 5 minus 1 over 2, which would be 4 over 2, which would be 2. These are the two solutions to this quadratic equation. Now, that means then we go back and we could check these answers to make sure that they're right if we put them in the original problem. But when you do, you're going to see that these are the two answers. And remember, we could write this in set notation such that, excuse me, I forgot. Let's make this x, set of all x such that x equals 2 or 3. Now remember, later on you'll be doing graphing parabolas. This equation, if you graphed it as f of x equals x squared minus 5x plus 6, if you put this into your graphing calculator as an equation, you'll get a bowl-shaped graph, which is a parabola. And as it turns out, these two solutions, 2 and 3, are the places where this graph will hit the x-axis. So you will be playing with that quite a bit in the sections where you talk about graphing and working with parabolas and quadratic functions. All right, now that one was nice. It came out to be nice whole numbers. It doesn't always work out that way though, as we'll see in the next example. Now here again we have a quadratic equation and it's set equal to 0, which means we're ready to solve. Now remember that the a value comes from the x squared term. So a is 3, b is -1, and c is also -1. Be sure that if there are negatives in front of these coefficients that you bring the negatives with them, because you will get the wrong answer if you don't use those. Now we're ready to substitute into the quadratic formula. So we have x equals, and again I put parentheses where the variable is. So we have the opposite of b plus minus the square root of b squared minus 4ac over 2a. Now b is -1, and that's very important, especially for the first part of that. A is 3 and c is -1. Now we simplify. Opposite of -1 is +1, plus or minus the square root. -1 squared is +1. -4 times 3 times -1 makes this +12 over, I forgot to write my a in down at the bottom, 2a, 2 times 3. So 2 times 3 would be 6. So now we get x equals 1 plus or minus the square root of 13 over 6. Now this is an example of a solution that we have the square root of 13. It's not a nice, neat whole number. What we would do at this point is simplify this radical if it will simplify. Square root of 13, 13 is a prime number, it won't simplify. So here we get now to the point where, depending on your instructor and what the problem's asked for, we either leave our answer. So one way to write the answer is that x equals 1 plus the square root of 13 over 6, or 1 minus the square root of 13 over 6. That would be the exact answer. You're leaving it up to someone else to do the square root of 13 so that you have, they can carry it out as far as they want. The other way then to do this is to take your calculator and calculate the square root of 13 and round it off. If we do that, we get 3.6055. So we would have 1 plus or minus 3.6 over 6. So if we split this into two solutions, we have 1 plus 3.6 over 6 and 1 minus 3.6 over 6, which we would then carry out. We have 4.6 over 6, which would give us, let's see, 0.7666. So we get 0.8 as one answer. And again, these are approximate answers, so they're going to be rounded off. They're not going to be perfect. And then if we finish 1 minus 3.6, we get negative 2.6 over 6, which when we divide this out, we get negative 0.4. Let me clean that up just a little bit, get it out. Okay. Negative 0.4. Now, if you, again, it's up to your teacher and the particular problem and what they're asking you to find. Either you will want the answers exact. Whoops, I guess I should learn how to spell exact. E-X-A-C-T. exact, or, let me finish, I wiped out my 6 there, didn't I? Okay, and wiped out my comma. Or you will have approximate. And in this case, then you would have x equals 0.8 and negative 0.4. The reason I put the 0 in front of the decimal is if you just put the decimal like 0.8 and you don't write it very darkly, it tends to disappear. So these are the two solutions that we get using the quadratic formula. And again, depending on your instructor and the question that you're doing, you would either leave them exact or make them approximate. So that is an example of not one that doesn't come out quite as neatly, okay? Now, the roots where you leave them exact, sometimes you will get an answer and you'll look in the back of the book and see that yours doesn't match the look of the final answer. That is because you have to go through and remember how to simplify radicals and then how to safely simplify that expression. So that is something for another lesson, but understand that you may need to do some work on reminding yourself how to simplify those correctly. Now, before you solve a quadratic equation, as we've said, it must be arranged so that it's equal to 0 and completely simplified. So, to summarize, solving quadratic equations, first of all, you have to make sure they're quadratic. Then you have two methods. You can factor, or you can use the quadratic formula. The quadratic formula will always work. It's your best friend. Learn it, use it. Usually when I'm doing problems, unless I'm teaching it, I use the quadratic formula because I know it's going to give me answers. Now, the other thing that I didn't show you, which you will get into later, is under that radical, you could get negative numbers. In a lesson that you have coming up, you will learn about complex numbers. The I, pulling out your eyes, yes, okay? So that will be one other type of answer you could get with the quadratic formula, but you go into that just a little bit later. So that's the end of this lesson. You can look in your text or your reference materials for more problems on this, but I hope you have a good day, and good night, Miss Calabash, wherever you are.